Okay, we are going to simplify the following logarithmic expression. So let's see what we can do. First thing, what I am paying attention, I have, in some cases, I have logarithm a by base b. In some cases, I have logarithm b by base a. When bases are different, we cannot do anything. We cannot combine, we cannot do any operations, right? So my goal is to convert different bases, convert into one base only. So it would be easy to work with. And this is what I'm going to do. Logarithm, let's say I'm going to bring by logarithm base by base b. Everything going to bring to logarithm by base b, which means logarithm b by base a. I'm going to do the following changes. Remember, we can use the property of logarithm when we represent by different base. Change the base. Let's say I want to use base b, which is going to be logarithm b by base b divided by logarithm a by base b, where logarithm b by base b is 1, and here we have logarithm a by base b, which means to switch the base and result for logarithm, all we have to do, take 1 over, right? That expression, or that logarithm rather saying. Which means this is what I'm going to do here. So logarithm a by base b to power 4 plus. So I'm changing the base here. It's going to be 1 over logarithm a by base b to power 4, and then plus 2 parentheses 1/2 plus 2 square brackets to power 1/2 minus logarithm a by base b and minus 1 over logarithm a by base b. So I switched all logarithms to base b. So now it will be easier to operate. All right, so what do we get from here? Power 1/2, that means square root, right? So I'm going to bring to common denominator this parenthesis. That's gonna be logarithm a by base b to power 4, and I will have logarithm a by base b to power 8, right? Plus 1 and plus 2 logarithm a by base b to power 4, right? So in all this square root, okay, and plus 2, and then this entire expression is also going under another square root. All right, and we are getting here minus, I'm going to combine these two logs also, logarithm a by base b, and I will have logarithm a by base b squared, and it's going to be plus because we have negative in front, right? This negative, we treat negative sign in front of fraction as a negative sign in front of parentheses because we are combining the negative sign in front of, we have negative sign in front of fraction, which means this minus 1 over logarithm a by b, it's gonna become positive, become plus. plus 1. Okay, from here, what do we have? So logarithm a by base b to power 8 plus 2 logarithm a by base b twice and plus 1, that's a perfect square where where my a is equal logarithm a by base b to power 4 and b is equal 1, right? And practically a plus b, it's going to be a plus b squared, which is equal a squared plus 2ab plus b squared. Okay, let's see what we're going to get. It's going to be logarithm a by base b to power 4 plus 1, right? Here it's going to be squared and divided by logarithm a by base b squared. No, it's degree 4, I'm sorry. 4a. Okay, we have square root and plus 2, second square root, and minus logarithm a by base b squared plus 1 over logarithm a by base b. Okay, so from here, as you can see, I have here square, and here I have degree 4, so I can take out of this inner square root, right? This expression. Let's see what we're gonna get. It's gonna be logarithm a by base b to power 4 plus 1, right? Without any parentheses, I don't need any more. And divided by logarithm a by base b squared. And this inner square root will be gone. We will have only one square root, correct? Okay, and minus logarithm a by base b squared plus 1 over logarithm a by base b. Okay, so from here, what further simplifications we can do? First of all, we are going to bring to common denominator, and it's going to be, here will be logarithm a by base b squared. In numerator, we'll get logarithm a by base b to power 4 plus 2 logarithm a by base b squared. I place first multiplication 2 by log a by base b. So to show you the formula would be seen much better, and only then plus 1. I just first I placed these 2 times this denominator and then plus 1. Because this way you can see clearly the formula a plus b squared. Okay, and this is gonna go under square root and minus logarithm a by base b squared plus 1 over logarithm a by base b. Okay, from here we are getting this expression in numerator. It's gonna be logarithm a by base b squared plus 1 and divided by log a by base b. All this is gonna be squared, right? Look, if I have, let me do drafting real quick, log a by base b to power 4 plus 2 log a by base b to power 2 and plus 1. Okay, this is going to be log a by base b 2 squared plus 2 log a by base b squared times 1 and plus 1 squared, where we have this is going to be a squared plus 2 this piece times a, and this is going to be b, and plus b squared. So we have a plus b squared, perfect square. Yes? Okay. Okay, put in parentheses with square and minus logarithm a by base b squared plus 1 over log a by base b. And from here, we are going to get, so we can take from out of square root, and we are getting logarithm a by base b squared plus 1. And here we have logarithm a by base b and minus logarithm a by base b squared plus 1 over logarithm a by base b. Now, what do we have here? Because we are taking from out of the square root, this logarithm a by base b, it's supposed to be, has to be as absolute value. So we make sure its positive value comes out, a positive and or negative, because we don't know which one is going to be right when it's come from square root, because square root of a squared is equal absolute value of a, right? Okay, and only then will be equal plus minus a. Okay, so this is our picture. Now let's see what we're gonna get, because we have it absolute value. So that means logarithm a by base b in denominator can be positive and negative. Let's look into two cases. So first case. Okay, let me use this one. Logarithm a by base b is less than 0. When this can happen? This can happen when we have b fraction less than 0, greater than 0, less than 1, and a greater than 1. This is one case. Well, let's see. I have logarithm, for example, 1/5, right? And a is 5. It's going to be equal -1, right? To get 5. So it's getting, our result is getting negative. Or the other option, it's going to be b greater than 1, and a is fraction between positive fraction. Let's check this one also. I have logarithm. Let's say I have 5 here, and I have 1/5. It's still going to be -1, right? Okay. So in both cases, we are getting logarithm a by base b negative, which means from here we are getting, since it's negative, we are getting negative sign in front of this fraction, logarithm a by base b squared plus 1 over logarithm a by base b and minus logarithm a by base b squared plus 1 over logarithm a by base b. And this is going to be equal negative 2 logarithm a by base b squared plus 1 over logarithm a by base b, right? I brought to common denominator. Yes? Okay, and this is equal. The final answer is going to be negative 2 logarithm a by base b plus logarithm b by base. Okay, let's go in details. I will go in details, 1 second. So this is going to be equal negative 2. Here in parentheses I have logarithm a by base b squared divided by logarithm a by base b and plus 1 over logarithm a by base b, which is going to give us negative 2. So this, in this case, this is gone with this squared. We have logarithm a by base b, and here will be plus, flipping back the base, right? We are getting plus logarithm b by base a. Okay, so this is the first answer. So this is when our denominator logarithm a by base b is negative. Now let's explore when it is positive. Okay, second version, logarithm a by base b greater than 0, which means we have b fraction between 0 and 1, positive fraction, and a also fraction. It's going to give us positive. Or b is greater than 1 and a is greater than 1. Well, let me bring some example for you so you can see. Let's say logarithm, again 1/5, here is 1/5. There we go, I'm getting 1 greater than 0. Second case, let's say I'll put 5 and 5 equal 1 greater than 0, right? Okay. So from here, we are getting our logarithm a by base b squared plus 1 over positive 1, right? And minus logarithm a by base b squared plus 1 over logarithm a by base b, and that is going to be equal 0. So what picture we have? So we get result 0 if both and a and b are positive fractions, or both and a and b are greater than 1. Then the logarithm result is going to be 0. And we get the result of negative 2. Negative 2 log a by base b plus log b by base a if the logarithm is negative, and logarithm can be negative if b is fraction, positive fraction, and a is greater than 1. Or the opposite, b is going to be greater than 1 and a is a positive fraction. Okay, so we are done with simplification. So thank you for watching, and I'll see you in next video.